Leveraging Kubernetes to modernize application infrastructures presents a number of opportunities as vendors already begun to package their applications and functions as cloud native, that within greenfield and brownfield developments. Proper automation is critical to lowering operating costs for operators and helping DevOps teams facilitate service creation and consumption, that with the use of Kubernetes. On this session to tell us how Kubernetes is offering complete automation with reduced human intervention are David Liu. He's Vice President of Software-Defined Platforms and Systems, that at AT&T. And we have Ravi Alluboyina. He's Vice President of Engineering at Robin.io. That is a Rakuten Symphony company. And gentlemen, welcome to the program. Ravi, if you don't mind, I'm going to start with you. What are the primary tenets to focus on when leveraging Kubernetes really to modernize application infrastructures?
Yeah, so there are two keywords there. One is Kubernetes, the other one is modernizing applications, right? And Kubernetes has become the de facto standard. It's unbelievable. In a very short time frame, it has become the de facto standard, both on the enterprise side as well as on the telco side. But I've been with Kubernetes for a long time now. What I realize is Kubernetes is pretty complex. Kubernetes in itself is complex, but it makes application deployment and managing the applications easy. The reason why it was able to do that is because it established certain tenets. There is application build, there is application run, there's application manage. As far as a build goes, it's building for virtual machines is one thing, but building for containers or a Kubernetes platform or a cloud native platform is a completely different ballgame. Virtual machines mimic bare metal servers. I mean, it means that application doesn't need to change at all. Very minimalistic changes. If you were to take an application that is running on bare metal and put it on virtual machine, you need very minimal changes. So onboarding becomes pretty rapid in terms of virtual machines. But for containers, there are predefined rules. Kubernetes came in with a very, very opinionated stack. By that, what I mean is, if you have to take an application and if you have to onboard on Kubernetes, everything has to change. Starting from breaking up the monolith, the application into microservices, creating containers, and creating Helm charts, and looking for CSI stacks, CRI, which is a runtime interface, and CNI stacks. So there's a complete change of mindset for the application builders. On the runtime, if you're coming from the legacy from bare metal on the virtual machines, you'll be used to stop and start of an application. It's as simple as service stop and service start. It is unbelievable that Kubernetes doesn't have a concept of start and stop. There is nothing, right? So imagine the mindset change from the operators. And same is the case with manage. I mean, how do you troubleshoot? These are containers. You cannot log into a container. There is no SSH into a container. It's blocked, right? So everything has to change. Essentially, I think the application vendors as well as the infrastructure operators have to focus on three primary aspects, which is build, run, and manage.
David, unless you have something you want to add, I was going to move on to the next question. Anything you want to add to that?
Sure. I just add one simple thing. It is just Kubernetes technology is critical for our deployment of the DevOps and the ultra agile development process transformation. And this is a critical technology we are counting on and depending on every day. Thank you.
Ravi, I'm going to go back to you. So along the journey to infrastructure modernization, do we continue to really maintain applications as is, or do they really need to be migrated, upgraded, or replaced?
Oh yeah, definitely. Definitely migrated as into the container philosophy. Application onboarding has been one of the biggest problems in the Kubernetes ecosystem. Just like I said, so the existing applications in their existing formats will not work on cloud native technologies. There is a shortcut, which is called the fat containers. Fat containers just mean instead of creating one virtual machine, you create a container with everything running in it. It's just like mimicking a virtual machine to run on cloud native, which is not a true cloud native way of doing things. Applications have to be migrated in order to leverage the primitives that Kubernetes provides. First of all, better resource utilization. If you split your application into microservices, you can better utilize your resources, because the CPU intensive pieces can be run on servers with more CPUs, and the storage intensive pieces can be moved to the storage nodes. And there are some special device requirements, for example, SRIVs and accelerator cards. So applications definitely need to change to move to microservices. And the second, one last point. The second point is that, like I said, the way of troubleshooting this application has changed drastically. If you split an application into 10 microservices, upgrade is a nightmare, because now you have to think about 10 different teams building 10 different microservices, the API compatibility, and upgrade in sequence or in parallel. There are a lot of things to take care. So applications need to change for sure.
David, back to you. From your vantage point, why have many vendors already begun to really package their applications and functions as cloud native within these greenfield and brownfield developments?
Let me reply by this. The first, I would like to add a comment to Ravi. Totally agree with him. But the migration to me also mean upgrade or modernization. And that it comes down to the next question, the true greenfield. In my area of work, there is not a single true greenfield. Even though we embrace the greenfield, even though some segment of network may become greenfield. But when you're connecting everything together, you inevitably going through parts of the network, then you make the end-to-end connection that is brownfield. So I think this is very important. However, why this Kubernetes technology is so important to us? As we embrace the tremendous challenge in our industry, you're talking about the operators, the volume driver is hitting us, which is very capital intensive. And also the speed of the adopted changes becomes critical how fast we can go out in a very competitive environment. So therefore, we used to say, okay, IT systems or the software systems, we go to 2 or 3 releases a year. Today, my organization largely does DevOps model for almost 75% of all my development work. And we are delivering almost every month, continuously. Every 2 weeks, there's an iteration. So when you think about that environment, not only that, we want to give ultimate power to our business partners' hands, instead of everything is custom built by my software team. And so therefore, in order to do that, what is the way to accomplish this? You need to reach the open API standards. You need to get microservices. Now, when you manage the microservices, it's easy to be said and done. Conceptually, everyone can do it. I just give you one area of my work. Within like a short 3 years, we developed more than 400 microservices. But then now think about the environmental issue and challenges. That 400 microservices, because AT&T's scale, that translates to more than 5,000 microservices instances in production. So how do you manage them? That becomes a huge challenge. I think Kubernetes in this environment, whether you call it greenfield or brownfield, it really doesn't matter. But the fact is of the scale and the speed of the changes and what the Kubernetes is offered to us, giving us the automation capability to deploy, continues to deploy, and the not only the cloud native, but the Kubernetes native capabilities we can use is just presenting us really great opportunity.
Ravi, anything to add?
Yeah, so David brought up a very good point about greenfield and brownfield. So total greenfield, I think at this point is not really feasible because, like I said, application onboarding is a big problem, and it is taking time for vendors to really adopt Kubernetes and bring them on board. So it's very important that we have a distribution or a framework where we can deploy both the virtual machine workloads as well as the container workloads and work seamlessly. Kubernetes has made that progress. In fact, we provide a platform to run both VMs and containers. So essentially, so we should get away from the world where we run virtual machines on OpenStack or virtual machine infrastructure and containers on Kubernetes. We should get rid of those silos, and Kubernetes can run virtual machines. So we should use that. So we can accommodate both greenfield and brownfield environments.
So Ravi, I'm going to stay with you, you sort of answered this question a bit, but let's go into a little bit more detail. So proper automation is critical to lowering operating costs. And of course, I could ask this question to David as well, but so how does Kubernetes hold the key for operators in that respect?
Yeah, I think this is one of the biggest promises of Kubernetes because Kubernetes is a normalized layer. Every application has to adopt or adhere to Kubernetes rules and principles. So what that does is it makes the management of the applications easy. Every application is a Helm chart. Every application has pods, PVCs, services, and config maps. So what it does is anybody who's trained on Kubernetes can effectively debug Kubernetes. Yeah, because they are the same primitives, no matter whether you're talking about an enterprise application like MongoDB, Cassandra, or Hadoop, or a CUDU in case of telco. The primitives are the same. As far as the pod and the PVC debugging goes, but application debugging has to be done by an application expert. So what Kubernetes provides is a unified application build layer, which is you define all the applications using a single format. It could be Helm or it could be operator. There are very few formats. A unified runtime. Like I said, you could run virtual machines or containers or database or a telco applications on the same stack. It provides a unified runtime. And it also provides a unified management stack, which is how do you upgrade? There are only a few options for you to upgrade. Like you create a different version of a service or the application and you route the traffic to it. It could be Canary or it could be blue-green updates and all that. So essentially it provides a normalized layer for building your applications, running your applications, and managing your applications. So that takes away the need for having different operators for different stacks.
David, I want to go back to you. So how can failures be really easily detected and automatically resolved without manual intervention, that with the use of Kubernetes? And I know that's a loaded question, but maybe you can give us an example.
Yeah, actually, there is, in our field, right, there is no perfect automation. Just like people say, there is no perfect technology. There is no best automation. There is only optimal automation. There's only choices of automation. Why I say that is the following. If we decide only use native Kubernetes in our environment, then hopefully the Kubernetes native capability will automatically detect if there's any issue, recovers any issue. That's the best automation. You don't even do monitoring because the system is self-healing. The problem is oftentimes with the implementation, you begin to use some more advanced strategies, such as, Ravi, you mentioned the blue and green, okay, canary type of approaches. Well, some of those tools require using additional tools. It's not native Kubernetes supported. So therefore, when you have the gradually, now the value of that, the advanced, the approach is that you want to minimize the impact to the user community. You want to ease your automation, your deployment. You don't have to touch multiple menu points. You do that. And when things happens wrong, the infrastructure will recover itself without intervention. That's the best, that's our goal. But then it's a complex question. It's the trade-off of which the advanced strategy you want to deploy, what the benefit you bring, what the additional cost of the resource utilization. For example, in this field, I'm sure that Ravi understands inside out, but I'm not sure the general audience they do, is because when you use the two different kind of parts approach, and you gradually, percentage-wise, do the traffic distribution. And during that process, what additional tool you needed to bring on board to continuously to automate that. And so therefore the cost, the trade-off on impact, the complexity, and how you manage it becomes a key challenge. But I think with that capability, certainly is offering a new areas of possibilities for us to tackle how fast we can move for the software industry. So which is a great thing to me.
And again, Ravi, I'm going to go back to you. And again, you guys have both sort of touched on this, but if we can go into a little more granular detail, that'd be great. So Ravi, how does Kubernetes allow DevOps teams to facilitate service creation and consumption, as I mentioned in the introduction, offering complete automation, again, with this reduced human intervention? I know that David touched on it a little bit, but if you want to go into more detail.
Yeah, so I think it all starts with microservices again. Git and Jenkins are so predominant these days. Everything goes to GitHub or Git or some version management system. And from there, Jenkins takes over, builds some source code, creates the containers. Here is the first change in the industry. Earlier, it used to be RPMs or Debian packages or ISO images or VMDK files, which are virtual machine files. The first change that got introduced is everything, the output of Jenkins is a Docker image. So, and from there, the second level pipeline and the Jenkins takes over and it creates a Helm chart or an operator. So second change. See, all the continuous integration and continuous development, the so-called CI/CD, is being driven by what Kubernetes needs and how microservices needs to be deployed. And CI/CD, I think, also brings in, it's trying to bring in the closed loop automation as well in certain scenarios where, if there is a bug detected, if there's a patch that is required, it's automatically relayed and a patch is applied, a Docker image is built, Helm chart is created, and then deployed again on the staging and then the production servers. I think David is living and breathing CI/CD, I believe, now that you mentioned there are 400 microservices.
David, anything to add?
Yeah, we at AT&T, my team actually is leading an effort to transform our applications into a service-oriented architecture, what we call network as a service. So in the past, we used to build our application as each silo, okay? And going forward, we're going to building those functional and domain-specific services as a service call. So basically, we adopted in a standard set of building blocks, including Kubernetes as infrastructure kind of a building blocks. And we apply those technology to deliver our services in the DevOps model. And then in addition to, on top of that, we allow our business partners, product team, operation team to come in to do model intent-driven, low-code and no-code development work on top of us. So they can make so much changes to deliver the capability they need without ever have to touch the code that my team builds. So that is, because of doing all of this, you can see that why microservices, the construct of the Kubernetes infrastructure becomes so critical to our field.
So Ravi, I'm going to go back to you, and again, we'll wrap the program with this. Can you offer an example of how Kubernetes provides the option for something called canary testing and the application of maturity models? Can you just give us some insight into that?
Yeah. So before I answer that question, Kubernetes made a very, very good decision in terms of how to connect to a service. Kubernetes has gotten rid of this concept of IP addresses, which was so very, very prevalent in virtual machines and bare metals, because once you assign an IP address, it's fixed, it's static for a VM or for a bare metal. Kubernetes came in and said, okay, no more IP addresses. And pods, that we don't restart pods. Pod die, we create a new pod. It could acquire a new IP address. So if it is acquiring a new IP address, how can an end user connect to it? Because IP addresses are assigned at runtime, right? So they came up with this concept called a service. Okay, so you don't worry about the IP addresses. And I give you a service. That is a promise of Kubernetes. You talk to the service and I'll route you to the appropriate application, right? So that's the first thing that they have done right. What that brings is, so we can replace the applications in the backend while preserving the service endpoint. So that aids immensely in upgrade options. It's either blue-green or canary. Canary means you have a new version of the application that is running and you want to channel portion of the traffic, user traffic, to that upgraded service. Now, like David said, so you need to bring in tools. One of the tools is Istio, which does pretty good. So Istio is a service mesh. They call it service mesh, but there are many services inside that. There's service discovery, service mesh, network traffic control, and all that. So Istio has this concept called virtual services and destination routes, using which you can route the traffic to an upgraded service. The flow would be like this. So you create a new version of the application. You deploy the new version of the application alongside the old version of the application, but not that big, a small portion of the V2. And then you go and tell Istio that route 20% of the traffic to the new service. And then you observe the behavior maybe for a week or a month, and then gradually increase the size of the new version of the application and decrease the size of the old version of the application. So which means you increase the traffic to the new version and you decrease the traffic to the old version. And finally, you upgrade your application without an impact to the end user. So you're not bringing down the whole thing to upgrade, right? It's a rolling upgrade.
So David, from an operator's point of view, we just have about a minute left. Do you want to wrap with any sort of futurist comment or sentiment on, again, the future of Kubernetes and shaping a cloud-native future?
Well, yeah, first off, let me compliment what Ravi just said. The tool said the ISTO, or whatever how you say it, this particular tool. We're using that in our environment too. I think it helps us for addressing the continuous testing, not only the continuous development and deployment, but the continuous the testing, and allow us to speed up the deployment into the field, allow our users to have a touch on it. Finally, let me just conclude by this. This is a journey. This is not one day and one item thing. The industry is evolving. The technology will get better, but the winner will be whoever is using the technology to its best advantage. So I'm sure that Rakuten and AT&T, we partner in many areas, but we also are working, have a similar vision to drive to the future where the software is a platform, software as a service, and network as a service, data as a service. We are moving toward this no return. Thank you.
Well said. Ravi, again, we have about 30 seconds. Anything you want to say?
Yeah, I'd say Kubernetes' future, there is no option but Kubernetes. Application vendors have to adhere to Kubernetes. That's good for the operators. What I'd say is, I think it's very important to have a hyper-converged stack where, so we don't go to like 10, 20 different vendors and get different pieces, because it's a nightmare to manage all of those things. It's good to have a cohesive Kubernetes solution, which includes security, which includes observability, which includes the runtime, storage, etc.
Ravi and David, thanks so much for your time. I know you have to get on to future appointments. We thank our speakers on shaping a cloud-native future with Kubernetes. For this session on demand, please go to thenetworkmediagroup.com. So long.